Now let's focus on finding the range of a particular function. We are going to be starting from linear function and gradually we'll be proceeding to the next types of function. So what I would suggest is that you need to first of all be familiar with how to graph functions, as that can always help you to get the range of any kind of function. But besides, we are still going to discuss that in this video, so just make sure you stick right from the beginning all the way to the end. So let's begin with this function. How can we find the possible value of y that this function can be? It turns out that the graph of a linear function usually used to looks like this. It's always a straight line graph. But it turns out that for this particular problem, it has an intercept along the y-axis, which is at 3. Then the graph is going to move this way. Now, the range are going to range from, or are going to move from the least endpoint of the graph. You can see that this is the least endpoint of the graph towards the negative y-axis and the maximum endpoint of the graph towards the positive y-axis. But unfortunately, this graph tends to keep on going all the way to infinity. So therefore, I have positive infinity to be this, and I have negative infinity to be this. And with that, we can make a conclusion that the range of a linear function usually is to range from negative infinity, my part, I use column bracket, we are using a parenthesis, open bracket. So from negative infinity all the way to positive infinity. And this is the range of any kind of linear function whereby the leading coefficient is simply 1. Okay, so in a case whereby you are having a function that its leading coefficient is more than 1, then please you have to be very careful. In this case, the range might not be ranging from negative infinity all the way to positive infinity. So what about if the leading term is having a coefficient of 2? What could be the possible value of y? Let's consider these three different quadratic function. Y equals x squared. Then let's say the y equals x squared minus 3. And lastly, let's consider y equals 4 minus x squared. Y equals 4 minus x squared. What are the possible value that y can be in all this function? My bad is 3. I actually want to write here. So this is x squared minus 3. So the first one, but first you need to be familiar with what we called the maximum and the minimum point of a quadratic function. If you are someone that usually used to work with quadratic equations or quadratic functions, you should know how the graph used to look like. A quadratic equation is always on the form ax squared plus bx plus c, where a, b, and c are constant value. Now, its graph usually used to be in two different ways, though its shape used to look like a parabola. But the parabola, the point or the faces of the parabola, where it will be facing, depends on the coefficient of the leading term, that is the value of a. If a is greater than 0, that is, if a is positive, then the graph is going to open upward, meaning that the graph or the parabola will look like this. And if a is less than 0, if a is negative, then the graph or the parabola is going to open downward. So that's one thing you need to keep in mind about quadratic functions. Now let's try to graph all these functions and figure out the possible value that y can be. Now for the first one, it turns out that y doesn't has an intercept. So you can always plug in points if you don't really know how to graph a function. So it's going to intercept at the origin. Okay, I don't know why I'm just trying to pass through the origin. So this is how the graph is going to look like. Okay, it's going to intercept at the origin. So it means it's going to ranges from 0, which is origin, all the way to positive infinity. So for the graph of y equals x squared, the range is just going to be equals to 0. It's going to include 0 as well, so I'm using a close bracket, then all the way to positive infinity. So therefore, it's going to move to positive infinity, and I'm going to use a close bracket, an open bracket. Now, for the sake of those who might be wondering how I got that graph, let me describe it for you. Let me just plug in points. Let's say I have a table whereby x is serving as the input for the first row and y is serving as the output for the second row. So I want to plug in region values. I want to start from -2 all the way to 2. I have -2, -1, 0, 1, and 2. What could be the possible value of y? When x is -2, what will be the value of y? It turns out that the function is that y is equals to x squared, and negative 2 squared is simply 4. What about negative 1? What could be the value of y? Negative 1 squared is simply 1. 0 squared is 0, 1 squared is 1, and 2 squared is simply 4. Now with this, I can just graph a particular function. So let's say I have my coordinates or Cartesian plane. So along the upper part, I have y-axis. Along the right or left part, I have x-axis. Okay, so for instance, I have 1, 2. This is 1 and this is 2. Okay, let's just work it out. So for this, I have negative 1, I have negative 2. Okay, perfect. Then along the y-axis, I have 2, then 4. Then along the y-axis, for instance, I have negative 2 and negative 4. That's along the negative y-axis. So when x is negative 2, y is simply 4. So a point is here. When x is negative 1, y is 1. A point is here. Okay. When x is 0, y is 0. Another point is here. Alright. And when x is 1, y is 1. Another point is here. And when x is 2 again, y tends to be 4. And another point is here. Now, by the time I join all these points together, you will see that it corresponds to the diagram I have over here. And that is how to easily draw a particular function using points. You can always plug in points for you to have a good and perfect shape. So therefore, its range is going to move from 0 all the way to positive infinity, regardless of the path you choose. This is going all the way to positive value, and this keeps on going to positive values. And that's how it works. Now let's consider the second one. By the way, you can feel free to pause the video and try to state out the range of this next function. If you haven't subscribed, please do wait to subscribe to my channel. Thanks for watching the video. I really appreciate it. So let's move on. Okay, now I have y equals x squared minus 3. Now this negative 3 is serving as the intercept along the y-axis. Okay, if we should keep on plugging points, it will consume a lot of our time. So this function, its graph, is going to look something like this. So I'm going to move 3 units towards the downward part. But fortunately, the coefficient of the leading term is still positive. It means it's going to open upward, and the graph will look something like this. Okay, so from here I have positive infinity, positive infinity, positive infinity, and this is negative 3. It turns out that the graph will ranges from negative 3, that is including negative 3, then all the way to positive infinity without including positive infinity. So this is a quick and easy way to identify or to state out the range of a particular function. Hopefully you are understanding the concept. So what about the last one? So I'm going to leave the last one for you as a practice problem. After solving it, feel free to post your answer in the comment section below, and I'm going to respond to it as soon as possible. So let's consider a cubic function, that is a polynomial function. What could be the possible value of y if y is indeed a polynomial function? So what did I mean by polynomial? Here's what I'm saying, extends, whereby the leading term is 3 or just an odd numbers. So when you have y to be equals to x cubed, you have y to be equals to s cubed plus 5x squared, and I said minus 4x plus 2, or you have y to be equals to x to the power of 5 or 7. Once the leading term is just an odd, then this is how you are going to find its range. But first, you need to be familiar with the visual illustration of the graphical representation of a polynomial function. It's going to look something like this. It's going to have two different extrema. Okay, it's going to have minimum point, maximum point in it. So usually used to look like this. And you have maximum point and you also have minimum point. And that is how um, a polynomial function usually used to look like. So it turns out that all the end behavior, okay, the endpoint towards the positive y-axis is still positive infinity, and the endpoint towards the negative y-axis is still negative infinity. So regardless, for any types of polynomial function, once the leading coefficient or the leading term is having the highest degree such that the degree is an odd number, then its range is going to move right from negative infinity all the way to positive infinity. And this is the range of such function. So keep that in mind. So it means for polynomial function or for function such that the leading coefficient is, is having a degree of odd number, and the linear function, their range will always move from negative infinity all the way to positive infinity. While for that of quadratic function, that depends. It depends on the kind of function you are given. Okay, so the next type of function we need to look in this video is called absolute value function. There's a very important thing you need to know about absolute value. If I have y to be equals to absolute value of x, if x tends to be two possible values, that's at -1 and 1, you need to keep in mind that the value of y will always be equals to 1. Absolute means eradicate negativity. If I have absolute of -1, then the result or the outcome is going to be 1. I don't want to receive negative. I always want to have positive value. But you need to keep in mind, because many students used to find this confusing. If you have negative absolute value of negative value, then this is simply -1. Because by the time the absolute value tends to turn the -1 within it to be 1, then the negative outside will multiply that one and makes it to end up being a negative value. So that is one thing you need to keep in mind. But that's not our main goal in this video. Our main goal is how can we find the range of absolute value function. So let's look into it. We have several ways in which we can have absolute value function, but let's just talk about the one I have with me right over here. So if you have y to be equals to absolute value of x, you have y to be equals to absolute value of x plus 3, and you have y to be equals to absolute value of x minus 2 plus 3, or minus 3, let's say minus 3. And lastly, you have y to be equals to absolute value of 2 minus absolute value of x minus 3. How can we find all the possible value that y can be in this function? Now, how does an absolute value function looks when representing it on a graph? It's visual illustration. It's usually a V shape, but it depends whether you are having an intercept or not. For this first function, the graph will look something like this. I'm going to run a test point for you so that you can see that um, the diagram is absolutely okay. So it's going to look something like this, as all the end behavior will be moving all the way to positive y-axis. So let's try to run a test point and see if this really work perfect. So let's say I have a table. Along the first row, I have input, and along the second row, I have output value. So I would like to use a range of value from, let me use -2 all the way to 2. -2, 1, -1, 0, 1, and 2. So when x is -1, y will still be +2. When x is -2, y will still be +2. When x is -1, y will still be +1. When x is 0, don't forget the absolute value of 0 is simply 0. That's y will be 0. When x is 1, y will still be 1. Okay, it's still positive. And when x is 2, y is still going to be 2. So therefore, let's try to plug in this point on a Cartesian plane. So let's say along the positive y-axis, I have 1, I have 2. And along the negative x-axis, I have -1, -2. Along the positive y-axis, I have 1, I have 2. And along the negative y-axis, I have -1, I have -2. So let me label it properly. Excuse me. So now I'll begin to plug in those points. When x is -2, y is simply 2. It's -2 of y or x, y is 2. When x is -1, y is 1. Perfect. For instance, when x is 0, y is 0. I have it over here. When x is 1, y is 1. And I have it back. And when x is 2, y is 2. And this will keeps on going forever. As you can see, it looks similar to what I did in the first place. So it's going to be like a V shape. And this is moving all the way to positive infinity along the left hand side, and along the right hand side also moving to positive infinity. So range is written from the least all the way to the highest. So the least here is simply at the origin, which is 0, and the range of such function will simply be from 0, including 0, then all the way to infinity. without including it. Okay, that's a parenthesis and not a close bracket. Let me write it properly. Okay, so hopefully you understand that. Let's consider the second one and see the difference between the diagram. Hopefully you are written that. So for the second one, I have y to be equals to absolute value of x plus 3. This 3 is serving as the intercept along the y-axis. Okay, so therefore the graph will look something similar to this. If you are wondering about how the graph look like, feel free to use test point to confirm the visual illustration. So this is positive 3 along the y-axis, and the graph will opens upward like this, and the graph will looks this way. So therefore the range in this case is just going to be from 3, including 3, then all the way to positive infinity, without including that. That's a close parenthesis. Okay, sorry, that's an open parenthesis. Now let's focus on the last one. For the last one, I would like to use points. I would like to use test points to confirm the visual illustration so that it won't seem confusing to you. Okay, let me just let me get rid of this so I can have enough space. So first, I have x minus 2 to be within the absolute value, then to be subtracted by negative 3. So a rough sketch of this graph is that it's going to look something similar to this, but we are going to confirm that. Okay, that's just what I think of. So negative 3 should be somewhere around there. But let's see. Let's use a test point. So I have x as input, I have y as output. So I'm willing to use negative 2 all the way to 2. So within them, I have negative 1, 0, and 1. When x is negative 2 minus 2, that's negative 4. And the absolute value of negative 4 is simply 4. 4 minus 3, that will be 1. I believe you want to grab that. What about negative 1? When x is negative 1, negative 1, negative 2, that's negative 3. And negative 3, the absolute value of negative 3 is simply 3. And 3 minus 3 is indeed 0. Now, what about 0? 0 minus 2 is simply minus 2. And the absolute value of minus 2 is 2. And 2 minus 3 is simply minus 1. What about 1? 1 minus 2 is simply minus 1. Absolute value of minus 1 is simply 1. And 1 minus 3 is minus 2. What about 2? 2 minus 2 is simply 0. And the absolute value of 0 is indeed 0. 0 minus 3 will become negative 3. Now let me graph this point on the Cartesian plane. So I have y-axis, I have x-axis. So I have the origin, I have 1, I have 2. So I have negative 1 and I have negative 2. So what I will do at this point is that I will label the y-axis as well. I said 1, 2, 3. Negative 1, negative 2, negative 3. Now I begin to plug in this point. At x equals minus 2, y is equals to 1. There's minus 2 and there's 1. So I have a point here. Add, okay, that was a mistake, my bad. This x equals minus 2 and y is 1. Okay, that's somewhere around there. Okay, when x is minus 1, y is 0, so that will be somewhere around here. Okay, let me use different color. When x is 0, y is minus 1. This is 0 and y is minus 1, somewhere around here. Let me circle that. Then when x is 1, y is negative 2. When x is 1, y is negative 2. I have a point around there. And when x is 2, y is negative 3. I have this somewhere around here. Okay, now I would like to increase the point towards the positive part of the x-axis because I want to know if it's going to form a V-shape, like it's just going to curve. I'm very sure it's going to curve, but for you people to see it yourself, let me just add to it. Let me say 3 and 4. So when x is 3, what's the value of y? So 3 minus 2 is 1. Absolute value of 1 is 1. 1 minus 3 is minus 2. 4 minus 2 is 2. Absolute value of 2 is 2. Right? And 2 minus 3 is minus 1. So when x is 3, so let's say for instance I have 3 and I have 4. So when x is 3, y is negative 2. You can see it begin to change right from that 3. So it's somewhere around there, -2. And when x is 4, y is -1. So that's somewhere around there. So this thing will keeps on forming a V shape, which keeps on going up, okay, to form a V shape. You can see it's similar to what we did earlier as this. So that is a quick and easy way to draw the graph of a particular function. Just try to plug in points as input and output. Then you begin to input them or insert them on the Cartesian plane. So the range in this case will be from the least all the way to the maximum. The least over here is -3. The least value, the value of y can be, and the maximum is positive infinity. So the value of y can keeps on going forever. So it includes -3, but doesn't include positive infinity. And this will be the range of this function. So what about the last one? So I'm going to leave the last one for you guys to use it as a practice problem as well. You can always post your results in the comment section below for review. So you have y to be equal to 2 minus absolute value of x minus 3. So you are still going to be using the same concept about everything I've taught you so far. And I'm very sure you are going to get its visual representation on the Cartesian plane. And with that, you can just try to take the range. Okay. Now, the next type of function we need to talk about is the radical function, that is the square root function. How can we find all the possible value that y can be if y is indeed equals to a square root value? So let's say we have y to be equals to square root of x. What would be the range of y? It turns out that for a radical function, its graph looks something like this. It's going to be moving from the origin, except it has an intercept, then moving this way. So its range in this case will move right from 0 all the way to positive infinity. That's how the graph keeps on moving. So the range for this particular function will be from 0, including 0, all the way to positive infinity. Now, I would like to confirm the visual illustration for you guys using the test points so that you can compare it with what we have over here. So let's consider some range of values, typically set of input and output, which consists of x and y. Now, since we can't have negative value within the radicals, which will lead to an imaginary number, it means x can range from 0 all the way to positive values. So I'm going to consider perfect squares. 0, 1, 4, and 9 is pretty much enough to sketch this graph. So when x is 0, y is simply 0. When x is 1, y is 1. When x is 4, y is 2. When x is 9, y is simply 3. I'm going to grab that on a Cartesian plane. So for instance, let's say this is 1 or 2, 4, 6, and I have 8. For instance, I have 10. So y is 1, 2, then I have 3. When x is 0, y is 0, that's the first point. And I'm going to circle that. When x is 1, y is typically 1. I'm going to circle that. When x is 4, y is 2. Okay, that's interesting. And when x is 9, y is 3, somewhere around there. So if I should join this point, we see that this graph keeps on moving all the way to positive infinity, starting from 0. And that is how we derive the range. Now, what about this one? What could be the possible value of y? Hopefully, you are within that because I need to get rid of it right away. So, what if you have y to be equals to negative root x? What will be the range? Now, a quick practice problem I'm going to give you right away is to use test points to graph the solution of this function. But right now, the graph is going to look something like this. It will be a graph that will be decreasing with an increasing rate. So it keeps on moving this way. Okay, typically decreasing with a decreasing rate. It will start from 0 and to be held in toward negative infinity. And its range in this case will be simply, don't forget, range is ranging from least all the way to maximum. That's negative infinity all the way to 0 by including 0. What if you have y to be equals to negative square root of negative x? Where could that be? So the graph will look something like this, and it's going to be heading towards this direction, and starting from origin towards negative infinity. So the range in this case as well will be negative infinity all the way to 0. So without including negative infinity, but including 0. So that will be the range of this particular function as well. So that is how to easily and mentally represent radical function on a graph and how to use it to find the range of that particular function. So let's consider this last one and see the difference. The one that is having an intercept. What if y is equals to negative square root of x plus 4, or let's say x minus 4, then plus 4. We have a plus 4 outside the radical function. So at this point, to have this being understood properly, we would like to use this point. So let's consider a range of values. Now, to avoid having an imaginary numbers, it means x, which is the set of inputs, can never be negative value. Okay, otherwise this function will become an imaginary number. So it means it could be a set of positive numbers. And even if it's going to be a set of positive number, its domain won't tolerate or be any value between or from 0 all the way to negative 4, all the way to 3, for instance, all the way to 3, because this will still keeps being an imaginary number. So let's start from 4 being 4, then um, let's move to 5, 6, and 7. So that can always work. So this is the set of input and this is the set of output. So when x is 4, we have 4 minus 4 to be 0, and the square root of 0 is 0, and negative times 0, that's simply negative 0, and that can affect the solution. So y will be positive 4 in that case. When x is 5, 5 minus 1 is 1, and square root of 1 is 1, minus times 1, okay, that should be minus 1. Minus 1 plus 4, that will be positive 3. Okay, that's perfect. When x is 6, so we have 6 minus 4, that's simply 2, and the square root of 2 should be, let me use my calculator at this point. So that's simply 1.4, for instance. And when x is 7, 7 minus 4, that's simply 3, and the square root of 3, that should be 1.7, and minus 1.7 plus 4, let's say minus 1.4 plus 4, that's 2.6. So instead of 1.4, 2.6 is what we are to have here. So we are supposed to have 2.6 right here. And for this, we have 1.7. 4 minus 1.7, that's 2.3. Or let me check properly. Yes, that's 2.3. So I have 2.3. So these are the possible values. So let's graph this function and see how it's going to look like. Okay. So if you have a Cartesian plane this way, then I have 2, 4, 6, then 8 along the positive y-x axis. Then along the positive y-axis, I have 1, 2, 3, and 4. 1, 2, 3, 4. Perfect. So when x is 4, y is indeed 4. So I have a point right here. Okay. When x is 3, okay, when x is 5, y is plus 3. So let's say that I have it right here. When x is 2, or when x is 6, rather, sorry, y is 2.6. It's 2.6 around there. Then when x is 7, y is 2.3. So let's say that I have 2.3. So also that, for instance, then the graph will keeps on moving this way. So this is how the graph will keeps on moving. Okay, perfect. This is the visual illustration. So it turns out that it's going to range from 4, then keeps on moving negative infinity. So therefore the range is going to be equals to 4, including 4, all the way to negative infinity. And this will be the possible value that y can be for this function. So now you know how to graph different types of functions. So the last type of function we are going to look in this video is called rational function. And in this type of function, I must announce to you that you won't really need to graph the function before you can find its range. Here's what you need to just do. Let's consider this problem. Let's say I have y, or let's say g of x, it might be f of x or g of x, to be equals to x divided by x minus 3, or 3 minus x, for instance. And you are asked to find the range of this function. What you need to do is to set y to be equals to f of x, since that is actually makes sense. That's the case there. So to be equals to x divided by 3 minus x. Then your main goal is to solve for x. Then I would like to cross multiply at this point. I have y multiplied by 3 minus x to be equals to x. Then I will expand. I have 3y minus xy to be equals to x. Then I will collect the like terms. I will subtract or add xy to both sides. I have 3x or 3y to be equals to x plus xy. Then I will factor out x as the common factor. Then I have 3y to be equals to x in a bracket of 1 plus y. Then I will divide both sides by 1 plus y. And finally, I have x to be equals to 3y, all divided by 1 plus y. Then what I would like to do in this case is that I'm going to replace y with x. Then I'm going to replace x with y. Or I can just leave it this way, okay? And just look for the domain of this function. To look for the domain of this function, you know, over at the top, I have just a linear function. At the bottom, I need to make sure that it is not equal to 0. So I will set y plus y to not be equal to 0 and y to not be equal to negative 1. So the domain in this case, which will be the range of the first function, okay, will just be the set. Okay, the domain will be equals to, okay, let me use open bracket or move from negative infinity all the way to negative 1, okay, without including 1, then union negative 1 all the way to positive infinity. So this will be the domain, and which will be also be the range of this function. So that will be the range, and that will also be the domain. Okay, that will be the range, and that will be the range. Okay, this is range because we find the inverse. We already find the inverse. So this is just the range. To find the domain, you are going to use 3 minus x and not 1 plus y. I believe we grabbed that. Let's consider one more to see the difference. Okay, so let's say I have g of x to be equals to 1 minus x, all divided by 1 minus x. Or let's say this is 1 plus x, all divided by 1 minus x, for instance. So how can we find the range of the function? Set g of x to be equals to y, then you just need to collect the like terms. Cross multiply. With that, I can have 1 plus or 1 minus x to be multiplying the value of y. So the cross multiply, I have y multiplied by 1 minus x to be equals to 1 plus x. And finally, if I should expand, I have y minus yx to be equals to 1 plus x. Then I collect the like terms by adding yx to both sides. I have y equals 1 plus x plus yx. Then I subtract 1 from both sides. I have y minus 1 to be equals to x plus yx. Then I will factor out x at the right hand side. I have y minus 1 to be equals to x in the bracket of 1 plus y. Then I will divide both sides by 1 plus y. I have 1 plus y, 1 plus y. And finally, the value of x will be equals to y minus 1 divided by 1 plus y. Then I will set this not to be equals to 0. 1 plus y must not be equals to 0. Okay, so the values that I'm going to have in that case will be the range of the function. So the range of the function will move from negative infinity all the way to 1. Okay, let me set that. Start negative 1. So negative 1 to include it because y must not be equals to minus 1. Union negative 1 all the way to positive infinity, and this will be the range of the function. Now you know how to find the range of any kind of function. Thanks for watching. Hopefully you gain something. If you haven't subscribed, please do well to subscribe to the channel now, as that is exactly what will inspired me in order to create a lot more content for you people. See you in the next video.